Hello, Anna. Welcome to the podcast. Very happy to have you here.
Hello, thanks for having me.
So we'll get started. Our first question,
Mhm.
Anna. Kindly tell us something about yourself, which we don't usually find in any of your social media profiles.
Um, Hello everyone. I'm Danush Shekhar. I'm a graduate student at the University of Illinois in Chicago, and I'm doing my studies in particle physics. Um, to tell something about myself that someone probably wouldn't find on social media handles would probably be difficult to answer because I would say I'm a guy interested in physics. I'm interested in building detectors and instrumentation work in the field of high energy physics. I love to run. Run a lot. At least I think so. And yeah, I'd like to sometimes push myself on the physical endeavors, but yeah.
Right now. Next, could you take a few minutes in explaining to us what your research interests are and what do you work on currently?
Yeah. Okay, so like I mentioned, I'm working in the field of particle physics or high energy physics. So the work that I do is mainly categorized into two parts. One is instrumentation work, and the other is physics analysis. So for instrumentation, I am interested and I'm working on um, particle detectors that would be used in future collider experiments. So, for example, you
Right.
have the EIC and
Hmm.
also future upgrades of the experiments at the Large Hadron Collider or the LHC. So, I'm currently working in the CMS experiment for the Large Hadron Collider at CERN, and where I'm working on some instrumentation work to improve or to propose an improvement in the um, particle in the innermost sensors of experiment. So these are sensors that face the highest radiation, highest amount of incoming data, and so on. So these are extreme conditions that we're dealing with, and seems to be very interesting for me. And on the other side, I'm working on physics analysis, primarily studying the properties of the Higgs boson as part of the
Hmm.
CMS experiment. Um, I've just begun that line of work this semester.
Amazing, man. And
Mhm.
moving on, could you talk about your life at NISER and how the atmosphere influenced you in making you do what you're doing today?
Yeah, I think yeah, NICER. The time that I spent at NICER was probably very influential. I would say in my life in both personal and professional aspects.
Hmm.
And in terms of academics, I would say the guidance and support that I've gotten from my teachers at NICER have been very impactful on both, again, my personal and professional line of work, and made met great many interesting people over there. Had the opportunity to spend some time with them and share some nice memories, I would say. Yeah, it was an interesting place in life.
Right now. And was your interest in experimental physics, to be specific, building detectors for future collider experiments and medical imaging, set from the start, or did it develop after you doing multiple internships in the topic?
Yeah, so I think for me, when I entered NICER, I had no specific interest. In fact, I was probably interested more in developmental biology than physics for that matter.
Oh.
But finally, I think I chose to major in physics. And then this was in the second year when we had to choose our major. And so I had 4 years left to decide on what I would want to do in the future or what field I would like to work in the future. So the approach that I took was I had 4 internships left, 4 summer internships. So I wanted to try out one subfield in physics for every internship. And so first time I think worked on nonlinear dynamics, and I felt like that was not a good fit for me. And so second, I went into high energy physics. I still remember the day when I walked into my advisor's room and asked him for an opportunity to work in his lab. And ever since that day, I think um, I was able to relate to the field in some sense and connect to the concepts involved more easily than other fields, I would say. So just based on a gut feeling, I thought I should, yeah, um, probably stay in this field. And every internship or project after that has been roughly around, instrumentation in high energy physics or applications to the detectors that are used in high energy physics. Having confusion, like, I mean, again, go with the gut feeling. Try out different things in your master's or bachelor's. This is the time to try out. You have the freedom to try out a lot of other things, and then once you pick and like some field, hone or develop your skills in the same.
Okay. Amazing. And can you talk about your master's thesis as well? But we got to know that it won the best thesis award. So can you
Mhm.
just talk a few words about it?
Sure. So yeah, so I did my master's thesis on gaseous detectors again in the field of high energy physics.
Hmm.
So this was an R&D project where I designed and constructed um, thick gas electron multiplier is what it's called. It's a type of a gas detector that can detect radiation or charged particles, and this was done under the supervision of many teachers. And so I was involved with designing and constructing this detector. And so then towards the final months of my master's project, we successfully got it working, and we were able to detect some radiation or charged particles from a radiation source. We were able to detect X-rays, to be particular, but yeah, we got it working, and we were able to characterize the detector. This was the bulk of my thesis. Although we were also able to support some measurements we took from the project with simulations that I did on a software.
Right now. So hearing softwares and how does artificial intelligence play a role in your research? We being in the era of AI and machine learning.
Mhm. Um, I think I mentioned, right. So in my graduate school right now, I'm involved in two directions: hardware work and physics analysis work. Uh, I mean, to summarize and answer, or to answer your question in a short way, both of the fields involve the use of artificial intelligence. So
Mhm.
in the hardware side, we are working on machine learning algorithms that can be implemented on the detector or on the sensors in itself.
Right.
And so um, and these are for sensors that can be utilized in experiments like the CMS or any collider experiments like the in the LHC and other experiments as well. And so where this helps is that this can infer properties of the particles that pass through the detector through the information we get from the cluster. And so I think, this is probably like a novel field, and we're working on both simulations, machine learning development or algorithm development, and also hardware side of things. On the physics analysis side, we're again using algorithms to, um, I would say, um, get better measurements or results from the data
Hmm.
that we have. Um, I probably wouldn't like to go into the details because this is sort of the boundary of where my knowledge lies as well, because I've just begun my physics analysis. I know I'm aware of where I'll be using it, but I'm not fully aware or fully knowledgeable about the details.
Right now. And moving on, we'll have a slightly non-technical question. Can you talk about your life so far, and if there are some cultural shifts which you love talking about, and if there is something you miss about NISER?
Um, so life in Chicago has been different for sure because I mean the first change I wouldn't say it's a cultural change, but first change I experienced after coming from spending most of my life in Bangalore and then 5 years in
Mm.
Bhubaneswar is the weather. So the weather here gets really cold during the winters, and that was something I had to get accustomed to. It's been 3 years since I've moved to Chicago, and the winters still hit hard. But cultural change wise, I would say things are a little bit different here, and similarly for someone to have lived here and moving to India, things will be different because the environment is different. Um, there are like good and pros and cons in both sides of the world. At the end of the day, we're all surrounded by humans, and um, yeah, and life moves on, I guess. Um, and one thing that I definitely miss from NISER is probably friends and colleagues, and also I would say tea. So you don't get tea very in a lot of places here. So it's not as common as
When was the last
uh,
time you were in Bhubaneswar?
you would in. I visited Bhubaneswar last year actually when I came to India to visit family and friends.
Good. Nice.
Yeah, I had a brief visit at Nigeria then.
Hmm. So moving on, Bhaiya, what are the most promising areas within high energy physics that could lead to groundbreaking discoveries in the next 10, 20 years? And with the LHC reaching its limits, what role do you see in future colliders?
Hmm. Um, First of all, there's no definitive or right answer to this, I guess, um, because discoveries, as the word means, is I mean it comes up when someone does something right. But I would say like hearing the lingo um, around wherever I work is, people are focused towards dark matter research or searches. There's also good work going towards studies of neutrinos. So if you look at experiments and funding for upcoming experiments, there's great interest in the field to discover dark matter candidates and also study um, more things about the neutrino, I would say. And all of these, I think, fall under the category of beyond standard model physics. So I think, have a good or decent handle on standard model as of now. We have verified it and discovered all the particles it says exists in nature, and now we're going towards beyond standard model physics. I would say, yeah, these are probably areas where new discoveries are to be made. I don't know the timeline or time scale. I'm not sure if it'll be made in the next 10 to 20 years or maybe even next year, who knows. But but yeah, these are probably the areas where I can think of. Again, like I said, there's no definitive right answer, but yeah.
And a slightly kind of commercial question. And how can high energy physics contribute to technological advancements outside academia in the near future?
Yeah, I would probably rephrase that question. I wouldn't say how can, but rather
In or
and also how will it contribute in the future? Because the reason I'm saying this is because I feel there has been um, work done in our field which has contributed to where we've had good societal applications.
yeah, right.
Um, I think the famous example that immediately comes to mind um, is our field or CERN inventing the www, and then we've also had applications using the instrumentation R&D that we have done go into fields like medical imaging or radiation therapy and so on. So
Hmm.
there's and I think there's also considerable amount of people working right now in our field in these directions. And these are also fields that I am partially interested in and would like to work in the future, especially with medical imaging,
Right.
where the sensors that we develop are, you know, of course, very fine-tuned for our applications or for our research and the environment the collider experiments produce. But there's the R&D that we've spent in terms of time and money in all of these directions have great potential use in fields like medical imaging and radiation therapy.
Right, Bhaiya. And the very big major concern of all the students who wish to pursue a career in academia or they want to get into industry is the funding. And with funding become more competitive, what interdisciplinary skills or directions can students pursue to maintain a competitive high energy physics research profile?
Yeah, that's a nice question. So, um, just to deviate a little bit from your question, I would say, I mean, if someone is interested in getting into academia or research, especially in the field of in any field for that matter, I think the first most important thing is to have good fundamentals and concepts with whatever a major field that you're working in, let's say physics for this example. Um, and if there is some spare time after that, apart from the time you spend in your coursework, there would you should I mean you can get involved with research through internships and which typically happen over the summer. Um, I think the mistake I would say that probably someone can learn from by looking at my experience is that I tended to focus more on, I mean, I gave a little bit more focus on the research work done in the internships rather than coursework. I wish I had spent a little bit more time, um, having the concepts to whatever relevant coursework right. But yeah, I mean, have like a balanced profile, have good grades, have a couple of internships where you've had good or significant contributions to whatever you were working on. Probably these two are um, some things that you can focus on throughout the period of your bachelor's or master's. And as you're approaching towards the end of your master's, if you want to apply to a graduate school immediately, um, slightly shift focus towards providing a good cohesive application, through SOPs, and it depends on where you're applying, but slightly shift focus towards some exams that you might have to give depending on where you want to apply to grad school, and also some time on the application itself, because these things take time. But yeah, something to keep in mind towards the end of your masters or right before application season.
Thank you so much. And looking back, if there is one thing you could go back in past and fix it, what would it be and why? I mean, I think I got the answer to this. You're talking about you should focus more on. You felt that you should be focusing more on your coursework. Is that it, or do we have
Yeah,
a
I
different
mean,
answer?
if I had the opportunity to go back in the past, I probably would do the same thing again, because um, sure, mistakes have been made. It's up to us to learn from those mistakes and move on and not ponder too much about what we could have done or what I could have done.
Hmm.
But yeah, if I had the opportunity to go back in time, I probably would do everything same way, because I am who I am right now because of the mistakes that I made and the experiences that I've had. And I feel like I'm in a good place right now, so I wouldn't probably want to change anything, I guess. I hope that's not a cliche answer, but yeah.
No, it's really amazing answer. And we are nearing to the end of the podcast. And one final advice for all the students from your side.
Yeah, yeah, I mean, come on, man. I'm a graduate student. I probably I'm not the right person to ask for advice, I think, at this point in life. But yeah, I would say probably no advice. Just live the life that however you want to. Make mistakes. Mistakes are fine. Um, Learn from them if you have to, and if you can, and have no regrets. I guess. Yeah, you have one life. Do whatever you feel is right. But yeah, be humble. Be kind to others.
You know, I think we are done. Thank you so much for your time. It was my pleasure having you here. I hope
Mhm.
you enjoyed the.
Discussion. Sure. I mean, thank you for having me, and it was nice to talk. And um, hopefully, people learn have something to learn from this, and
Sure.
all the best for whatever you're pursuing.
Right. So thank you so much. Now have a good day.
Thank you.